Okay, so let's do a whole bunch of grab bag examples out of 11.5. Cool. The fundamental thing that we should learn, maybe, is that when I write log without a base, what do I mean?
Log 10.
I mean log base 10. When I write ln, I mean log base e. Okay, so that's e, the Euler constant. That's this number that gets used in science that's like 2.718 something. This is a fundamental thing for calculus, actually. So this is a good idea to put in your head. For some reason, that number is really special. Cool. We'll talk about why at another point. Let's see. So if I'm doing log base 10 of a times b times c, what can I do with my rule to that? Or my rules? Can I simplify that? Can I make it easier or different at least? Maybe different is the right thing.
You can just have log 10a plus log 10b plus log 10c.
Yeah, I could make it into log of a plus log of b plus log of c. Is that simpler? I don't know. Is it more useful in some situations? Oh yeah.
Yes.
Cool. All right, how about the other one here? Second one, I've got log of y to the fourth. What can I make that into? Which rule do you use? The one about powers, right? Okay, so the powers one says I can what?
Well, it'd be 4 times log y.
Yeah, we can drag the power down front, right? So the way I usually encourage kind of students to do is something like this, right? I can pull that power down front. Okay, how about log of x plus y?
You can't simplify that at all, can you?
I don't know. Why not? Convince me.
Well, because log of x plus log of y, you can't separate them into two separate things because then it's the same as log x times y.
See that?
Not the same thing.
This isn't something my rules tell me about, right? Because logs are questions about exponents, right? And adding exponents is fundamentally different than multiplying exponents, right? Or adding two numbers, right? If I tried to add b to the n plus b to the m, I don't have a rule for that. It's just b to the n plus b to the m, right? They don't fit together. Those things aren't like terms. So this guy is just what it is. That's as simple as it's going to get. I can't even change it, right? You guys see that? So there's a whole category of false log rules, which is that you do something that looks kind of similar. Be careful with them, right? If it's not exactly one of your log rules, it's not a rule. How about log of x squared? What can I do with that?
2 log x.
I pull a 2 down, bam, 2 log of x. Better have an equal sign there, right? All right. How about the ln of root x? By the way, we say that natural log. So the natural log of root x. Good. We just take this power, right? Pull it down front. So I get 1/2 log of x. Natural log. You guys see that? Just playing along, right? Squared is the 1/2 power still. So we just take the 1/2 down. All right, how about this guy? I've got the natural log of x squared times y squared.
Would that be 2 natural log x plus natural log y? Or would it be 2 natural log x plus 2 natural log y?
Okay, cool. Good question. Both. So it depends on how you look at it. So one way of looking is for me to say, okay, this is log of x squared plus log of y squared, right? Then I could pull the power down on each of these, right? I'll get 2 log of x plus 2 log of y. Right? That's one way for me to look. Another way for me to look is to say, okay, this is log of x, y, both squared, right? Now I can take the power down front, so I'll get twice log of x, y. Then I could use my addition rule to break it up. So I'll get 2 log x plus log y, right? But I'm actually an idiot. What did I lose?
Around log x and log y.
Yeah, there better be parentheses around that stuff. Because really, I meant to replace this thing with that stuff. So I needed parentheses. See, those are the same by distributing. This is going to be really common. When you start doing harder log problems in the book, you're going to find that your answer in the back of the book are going to be different fairly often. Okay? That doesn't mean that yours is wrong. That just means that they've used some log rules to rearrange in maybe a different way. Cool? You guys want to do, how about this one? So log of x squared plus y squared.
2 log x plus y.
Why can't you do that?
Because it's addition.
Because there's addition in there, right?
But when you do addition, when they both have a 2 in front of them, you can still put it, no, for up there when you're doing logs.
Yeah, so up here, I was dealing with multiplication, right?
At the end process, the 2 at the end are both equal to the same. So why aren't they equal to the same when it's the same power?
I think it means like, can you put 2 natural log and x plus y?
Because x plus y
because x squared plus y squared isn't x plus y quantity squared, right? You lost the cross terms.
Yeah.
Okay, see that? I can't write this as a square of something. It's not going to be. So this is as good as I can get. You guys see that? If it was a difference of squares, I could factor it into a couple of things, and then I could use the multiplication rule. But that's not even a difference of squares. I can't even factor this. You guys see that? So remember, there are false log rules, right? Things that you make up in your head that look a little bit like a log rule. If it's not one of the 3 over there, it's not a log rule. All right, how about this dude? What's my first thing?
Okay, first you
Get
can
rid of
put
the
that
5.
5 in front of everything.
Okay, so pull the 5 down. So you got 5 log of x squared y cubed over z to the 5th. That one.
Put 5 big parentheses.
Okay, so this is 5 big parentheses.
Throw out a little bit. The natural log, or ln at 2 ln x.
Okay, so let's do it in pieces. So
Plus 3 ln y minus 5 ln z.
good. So it's log of x squared, right? Plus log of y cubed minus log of z to the 5th. You guys all see that? That's from saying, okay, that's multiplication and a division. So I add these 2, subtract that one. You can do that in 2 steps if you want.
So now we just pull all those exponents and
Yep, and now we can go through this fun thing where we drop all the exponents. Right, so we get 5 times the whole thing, 2 log of x's, plus 3 log of y's, minus 5 log of z's.
If you really wanted to, you could distribute 5.
Yeah, and then if we really wanted to get super crazy, we could distribute the exponent or the 5 through. So we get 10 log of x plus 15 log of y minus 25 log of z.
would you want us to do that on the test, distribute?
At this point, I kind of trust that you can distribute.